All right, welcome back. We are in Unit 1 still, and we're on Lesson 3, Pure Substances versus Mixtures. The objective for this lesson is that you'll be able to classify a sample of matter as an element, compound, homogeneous mixture, or heterogeneous mixture. You can go ahead and look at all the key vocabulary terms. Pure substance, mixture, element, element symbol, phase, mixture, homogeneous mixture, heterogeneous mixture, compound, chemical formula, and just mixture. I just like to pronounce them for you because I think it's helpful when you say them in your head to say them the correct way. So the big idea of this lesson is that the things around you, and so I just happened to choose one thing that you could pull out of your fridge, maybe, like French dressing here. The stuff around you is made up of matter. Remember, matter's anything that has mass or takes up space. And that matter is made up of either one type or several types of matter. And most of the things that you look at are mixtures. So for example here, the French dressing is a mixture. All these things are mixed together. The mixture is made up of compounds. An example of a compound would be calcium disodium. And that compound is made up of elements. So we're going to talk about how most of the things that you look at around you are mixtures, but how those mixtures are made up of smaller components. All right, so matter is broken down into two different categories. All right, no matter what you pick up in terms of matter, it's one of these two types. The first is pure substance. The other one is mixture. A pure substance is matter with a uniform composition from one sample to the next. So that basically means, well, we probably need to know what uniform means. So think about what it means to wear a team uniform. You do it so you all look the same, right? So a pure substance is matter with the same composition from one sample to the next. Remember, this is what it's made up of. So what it's made up of stays the same from one sample to the next. So even if I have 3 buckets, all with some sample of matter, if it's a pure substance, it doesn't matter whether I grab it out of here, 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 it's always going to be made up of the same stuff. Now, I understand that probably doesn't totally make a whole bunch of sense. You probably can't picture in your head what a pure substance is. So we're going to keep going here, and I'm going to give you 2 examples of pure substances, and I think it will help clarify what that means. All right, so I'm going to come back to mixtures in a little bit. All right, so we're going to look at pure substances. There are 2 different types, and this will help you understand what pure substance means. There's elements and there's compounds. An element is the smallest unit of matter. You can identify elements because we have this amazing, beautiful document called the periodic table, which we use all year, and it literally lists out all the known elements. This is an old periodic table. We keep making new elements, so these are actually filled in. If you end up looking at any other periodic tables on the internet, you'll actually see different elements there. I'm going to zoom in even further here to just look at a particular element. So the very first element is hydrogen, right here, and you should just be able to look at the periodic table and tell me that hydrogen is an element, and you should be able to tell me that its symbol is just a capital H. That was one of the vocabulary terms, was symbol. The symbol for beryllium is Be, and the important thing here is that you notice that the first letter, if there's 2 letters, is always capitalized, and the second one is lowercase. When we get into compounds next, and you look at a compound like NaCl, you can tell that there's 2 elements because there's 2 capital letters. All right, so I'm going to make that small again. The other thing I want you to know about elements is that when if you were to draw a model of an element, you would represent it as a single circle. So if I was representing H, that's sort of how we show it's the smallest unit of matter. All right, if I want to draw an Na, I would draw it like that. The last thing that you need to know about elements are that they are a single phase. Now, phase is a vocabulary term, and it's this pretty unscientific definition, but I'm just going to simplify it here. Looks like one thing. And I usually hate the word thing, but I'm not sure how to describe it. If you look at an element, you're always going to see one phase. So look at some examples here. Elements that you're familiar with are usually metals. So think about aluminum. Aluminum foil looks like one thing. It's one phase. Other elements you're familiar with, gold here, AU, gold looks like one phase. Copper looks like one phase. Silver looks like one phase. Because it's all made up of the same atom, it looks the same. So the other thing we're going to go into, the other type of pure substance, is a compound. That is when two or more different elements chemically are bonded together. So that would look like something like a sodium atom bonding with a chlorine atom. And you show that they're bonded by basically having them touch. Like, that's a common way to represent compounds in chemistry. Another thing you need to know is that compounds also have a single phase. So again, when you look at a compound, it looks like one thing. Even though there's two elements bonding together, it looks with your eyes like one thing. And finally, the last thing about compounds that you need to know are compounds are represented by chemical formulas. Sorry, I can't erase that. Formulas. So the most common one that you're familiar with is H2O. Some other ones you're probably familiar with, table salt is NaCl. From biology, you know carbon dioxide is CO2. These are all examples of chemical formulas, and you're going to notice that they're made up of two or more elements that are bonded together. Okay, so now we're going to go into mixtures. Remember, the difference here is that mixtures have a composition that changes or varies from one sample to the next, which was different than a pure substance, which did not vary. So again, I think this is best understood if you look at the two different types of mixtures. The first is homogeneous mixtures, and it's a mixture that has a single phase. Now, the prefix here is very, very helpful in remembering that, because the prefix homo means same. So homozygous, you learned in biology, are two alleles that are the same. So I know I'm asking you to remember a lot here, but that would be like big A, little a, little a. That would be homozygous. Homosexual means that you like somebody of the same gender. So that comes across with the single phase. Examples of that are when you look at Gatorade or Powerade, either one, it looks like one phase, but it's a mixture because every Powerade that you get is not going to have necessarily the same composition. Meaning, Powerade is a mixture of things like water and sugar. So you cannot guarantee me that every single Powerade that you ever will buy has the same exact amount of sugar in it, right? It's just mixed together, so it could vary from one Powerade to the next. All right. Steel is another example. It looks like a metal. You might think it's only made up of one substance, but it's not. It's a mixture of substances that looks like a single phase. It's made up a lot of times of things like copper. Oh goodness, I don't know if I remember all of them. I think it's made up of chromium. I don't even want to guess here, but it's made up of several different metals in carbon. The other type of mixture are heterogeneous mixtures. Again, before I even tell you the definition, look here at the term hetero. Hetero means different. So heterozygous meant you had different alleles like big A, little a. Heterosexual means you like somebody of a different gender. So the different comes into play because it's matter that has two or more phases, meaning it looks like two different things. So a very easy example here is a salad. I can clearly see several phases. I can see lettuce, I can see cranberries, I can see walnuts, I can see cheese. And the same thing with the cake here, I can clearly see different phases. So that's going to be a heterogeneous mixture because all the things in here are mixed. They're not chemically bonded together. The same is true over here. The sugar and the water are mixed. They're not chemically combined. Here, they're melted together, all the metals, so they're physically mixed together. They're not chemically combined. All right, so I recognize that I just gave you a lot of definitions and a lot of information, and I asked you to understand the difference between all of them, and you are probably feeling this right now, probably overwhelmed with all the information. So don't scream. I think we should just go over the key concepts here. And this is a perfect picture because I was actually going to talk about salt water. So let's say you pick up some salt water in a bucket or something. Salt water is sodium chloride, and it's actually water, which you know is H2O. So these two things together are not chemically bonded. They are mixed together. And I know that because even if I didn't know that they were mixed together, I could just figure that out because think about making salt water. I could have one bucket and have a certain amount of water, and it could have a bunch of salt represented by those red dots. It's a mixture because I could take a bucket and take some salt water from a different area. Let's say I go to Europe and grab salt water. Maybe the salt water there only has a little bit of salt. The fact that the amount of salt differs from one sample to the next makes it, by definition, a mixture. And that's why we say that its composition varies from one sample to the next. Here it's composed of a lot of salt, and here it's composed of a little salt. So that would make salt water a mixture. But the mixture is made up of two compounds. Okay? The two compounds are the NaCl and the H2O. The reason that they're compounds is because, which is a pure substance, remember, is because no matter where I get these compounds from, whether it's Africa, Europe, the United States, wherever you get NaCl from, it's always going to be NaCl. It's always going to be one Na bonded to one Cl. Okay? H2O, it does not matter where you get the H2O from. It's always going to be one H and two O's. The composition never varies, okay, which makes it a pure substance. Now we can take it one step further and say that these compounds are made up of elements, right? The sodium chloride is made up of two elements, while the water is also made up of two elements, hydrogen and oxygen. There's no unit that we can break this down into any smaller than an element. All right, I hope that didn't confuse you further and you feel a little less overwhelmed. Make sure you write down questions for tomorrow because we will certainly go over lots of examples to help you understand all of this. All right, so again, I know it was a lot of information, so here's your test to see if you grasped the definitions that we went over. You're going to identify each of the following as an element, compound, homogeneous mixture, or heterogeneous mixture, and then once you do that, you're going to classify it as a pure substance or mixture. So what I want you to do is actually pause me and try these, and then you can play and you'll hear the answers with an explanation. All right? So here I go, I'm going to go over these. Number one, carbon dioxide. I would classify this as a compound. The giveaway to me is this chemical formula. Anytime I see a chemical formula, I know right away that it is a compound. That's all. That's your biggest clue right there is the chemical formula. Number two, cookie. A cookie, I have to think about what it's made up of. A cookie is made up of, I don't know, flour, sugar, salt, butter, a lot of things. And all of those things are mixed together. And so therefore, I would classify a cookie as a mixture. So do you hear me thinking about what it's made up of and how it's made? And then I further have to think about what type of mixture. I ask myself how many phases I see, and I know that a cookie, I definitely see more than one phase, so I would classify this as a heterogeneous mixture. Oops, and I realized in number 1 I didn't go over if it was a pure substance or mixture. And it's, if I say compound, compounds are all pure substances, so that's how I knew it was a pure substance. All right, number 3, nitrogen. Nitrogen sounds like it's an element, and if I wasn't sure, I could check the periodic table. You should be familiar with nitrogen by now from your previous science classes. And if it's an element, therefore, it is a pure substance. Last one here, coffee. Coffee, again, I'm thinking of what it's made up of. It's like coffee beans, water, you can put sugar in there, and all those things are mixed together, which would make it a mixture. And I ask myself again, do I see one phase or more than one phase? And when I look at coffee, I'm picturing coffee that is one phase. It all looks like one thing, which would make it homogeneous. Now I've had people say, oh, well, what if there were coffee grinds in it and I could see the coffee grinds? Well, then you would tell me it was heterogeneous. So it sort of depends what you're picturing in your head. All right, so that wraps up this lesson. Come in tomorrow with questions and we'll go over some more examples and hopefully we'll wrap this all up.